Welcome to lecture series 8051 microcontroller. In today's session we will discuss about some serial communication in 8051, how to write the program. So, for transmission purpose we have a TXT line. Via the TXT line we are transmitting, right. So, that line is how we are transmitting means via the some special function registers. In 8051 we have some specific functions for the serial communication, like two pins we have RxT and TXT. The two pins, TXT for transmitting the data, RxT is for receiving the data. Okay. So, whatever the data you want to transmit, that should be loaded in the SBUF. That is one of the special function register. That special function register data to be loaded in the buff. From the buffer only it will move to the transmission line. Okay. At the same time, the data received via the RxT line means the received data will be loaded in the SBUF. So, once the data is received and stored in the SBUF means the SBUF is full. SBUF is full means it is end with the 8 bits. Once it is full means then it will activate the RI. RI is a receiver interrupt. So, what it indicates, the data is received, now it is available in the SBUF. Now, this interrupt will move to the microcontroller. The microcontroller what has to do means it have to read the data. It has to read the data from the SBUF register. Once it is read means it become empty. Now, it is ready to receive the next data. So, before that we have to clear the RI, then only it will receive the next data. So, this is the way we are receiving the data. Suppose if we are transmitting the data means first we have to load the required data in the SBUF, then it will be transmitting. It will transmitting the data bit by bit, D0, D1, D2 up to D7. After the D7 we are giving the stop bit. During the halfway of the stop bit, now the TI will be raised. TI is raised means transmitter interrupt. What it indicates to the controller is, now I have transmitted the data, buffer is empty. If you have a successive of character to transmit, then it requests the controller to load it, right. Then it will load the data. So, before that we have to clear the transmit interrupt, then only the process will be repeatedly occur, right. So, by this way the data SBUF is full or empty means the TI and RI will be activated to interrupt the microcontroller for read and write operations. Okay. So, before that this serial asynchronous communication, it will supporting for the different baud rates. So, the baud rate to be loaded into the timer, then only according to that the wavelength will be varied, right. So, the pulse width will be varied. So, for that we are using the timer 1, the TH1 most frequently we are using for this purpose with the auto reload. So, for that we have to know how to calculate the baud rate. Generally we are calculating the baud rate, the system clock frequency divided by the 12, because the clock frequency is generated for the one machine cycle, that will be divided by 12, then it will be divided by the prescaler value 32. Then finally we are getting that baud rate should be divided by your required baud rates, okay, that you are getting in the decimal values. The decimal value should be loaded in the hexadecimal, then it will be loaded into the timer, because the microcontroller will execute only the hexadecimal values, that is why we are converting. So, the baud rate calculation also very important in serial communication. The next step is we have to activate the SCON register. SCON register is serial control register. There we have to activate which mode of operation, either 8 bit or 9 bit, right, receiver enabled, that kind of control informations you have to give it. After these three functions, then we are starting the transmissions. Okay. So, in today's session simply two programs we will start and how to write. Now, consider the program. Write a program to transfer good character, right, good word using the serial communication. First I have to calculate the baud rate. So, how we are calculating the baud rate means already we discussed, right, the system clock frequency divided by 12, then again divided by 32, you are getting the value of 28,800. This value is divided by 9,600, then you get the value as 3. The 3 should be subtracted from FF, then what do you get? You get it as FC. Repeat, FF minus 3 you get the value of FD, right, F, E and D. So, 3 values are reduced, you get the value of FD. okay, this value to be loaded in TH1. This is the one condition. Then based on these conditions we have to activate the SCON. Then what is this timer 1 we are using means, for this we have to give a TCON. So, TCON, SCON have to activate, then along with that baud rate we have to do it. So, first initialize the T mode with the auto reload function, right. Then baud rate is calculated with the FD value. Then SCON format, according to that we will do it, then start the timer, then load the value SBUF in the given word, right. So, first we will give the G, then O, D. Either you can give 1 by 1 or you can initialize the memory and call it 1 by 1. So, for the given specification in the SCON, first I have to give it as 8 bit, means these two are 0, the interrupt also initialized with 0, then the receiver enable is 1, activated in the mode 1. So, 0 1 I will give it. So, the value is 50 H. So, 50 H to be loaded in the SCON. For timer 1, for timer mode, right. So, here M0, M1, this 4 for the, so this is for the T0 register, this is for T1. So, now I am using the T1, so I will give it as a auto reload, means 1 0, then use it as a timer. So, will 0, here it is not used, so initialized with a 0. So, now the value is read it as 20 H. Okay. So, the timer mode value was read it as 20 H, then baud rate is read it with FD, then the SCON value is loaded at the 50, then start timer 1 along with SBUF. Now, we will discuss the program how to write. So, whatever the value is calculated, we have to initialize it. So, timer mode 20, right, then the baud rate, this is a timer 1 initialization, this one is baud rate, then this one is SCON initialization. SCON initialization for 8 bit, right. So, 8 bit in mode 1 automatically it also gives a 10 bit of frame. So, everything is initialized, right. Now, I have to start the timer. So, once the timer start, now I have to move the character, right. So, first I will transfer G to accumulator. After transmitting, instead of immediate passing, I will give the delay till the completion of the first data. So, first I will transmit the data G via the accumulator, then I am calling the delay. After completing that, it will return back, right, then O will transmitter, then it going to delay. So, what the value, similarly the O and D are transmitted, then I will stop the process, or you can repeat it. So, automatically what will do, good word will be repeatedly comes. Okay. So, either you can repeat it or you can stop it. So, what the internally the delay is functioning, the delay is functioning means via the SBUF only we can transmit, right. So, the given data is moved to SBUF. If it is a single data, you can use it move, suppose you want to transmit only G, means move SBUF comma 71 you can give it. So, what it represents, the 71 of its corresponding ASCII character G will be transmitted. Then once it is transmitted means we are expecting the 8 bits are transmitted, that is the frame size is 10, frame size is 10. So, 10 means the 10th bit, which will indicates the stop bit. During the stop bit halfway the TI will be enabled. What it indicates, the data is completely transmitted. So, for that we are repeating the process till or making the delay till TI is set. Once it is set means then we are exiting, we are clearing, then only we are returned back. Return back to here, right. What it represents now, it is ready to receive the or transmit the next character. So, next character I will get it as O, the O is now moved to the SBUF, then till its complete transmission the process is repeated. After the 10th bit it will exit from here, then it will clear, then it will move to the next character. Next character also O, then after getting into accumulator now it moved to the SBUF, the same process, right. And finally, it comes to that receiving of D. D is 68, 68 is moved to SBUF. Now till the 10th bit the process is repeated. At the 10th bit the TI is set, the TI set means it will exit from this repeated loop, then it will clear the TI, then it will be come to here, what it represents, short jump again. So the process is repeated. Okay. So this is the way we are writing the program to get, if suppose here the good word is a small one, here the good word is small one, so I have used in the 4 separate line, by calling the delay I have used it, right. Suppose welcome or bigger words, or suppose one sentence if you want to transmit, means you can initialize the memory, move dptr comma that specified address. Then you can load the data into that and call it one by one and initialize the counter value, how many character you want to transmit. Suppose 20 characters means you initialize the counter 20. For 20 times you call it access the data from the data pointer and load it, the same process only repeatedly occur. That is why you can initialize as a loop. Here the minimum number, that is why I have used it in the separate line. Now we will discuss the next program, which is used to receive the data. Okay. Write a program for 8051 to receive a bytes of serial data and display in P2, that is port 2, with a baud rate of 2400, with the SCON is 8-bit data only receiving with a single stop bit. In the frame formation, what I said, data or 8-bit informations along with the start and stop bit we are adding, right. Start bit should be 1, stop bit more than 1 you can add it. So that is why here we are specifying 1 stop bit in mode 1, right. So for this program, what are the things we have to do it? First we have to activate the T mode, then find the equivalent baud rate, then SCON. These 3 things you have to calculate it, then only we can start to write the program. So actually what it states means, one of the switch I have connected, right, switch is connected, the data via this I want to store into the port 2. So I want to display it, right. So this is a 8051. So via the switch means automatically here SBUF, that is the internal functions. So this is a port 2. So 8 ports are there, right. So suppose I am using the port 2 means 8 LEDs I have to connect it. So one of the switch is connected in the 8051, the data I want to display in the port 2. So port 2 consists of, this is a port 2 8 signals which consists of the LED. Okay. So among these 8 LEDs commonly grounded. So whatever the switches, this is a single switch that will be display on the P2. Suppose if you are receiving the data 0, 1, 0, 1, 0, 1, 0, 1 means here the alternate LED will be glow like this. The first LED is off, right, the second LED will on, then off, then the last LED will on. So this way alternate LEDs will be blink or on in the port 2. So for this process what we are doing means this data to be moved to the SBUF. SBUF means via the accumulator we are reading, right. So that SBUF is moved to the port 2 conditions. So before doing this operation, these 3 to be activated. These are the steps we have to follow it, right. So initialize the T mode for timer 1 with auto loader. So timer 1 means this is a timer 1 for the last 4 bits, this is a timer not. So here which are unused datas you can give it as a 0. Here timer 1, so I am giving it as 0. With auto reload means it is a mode 2. That is why I am giving the value as 02. So finally it is a corresponding hexa equivalent, that is 4 bits, I will read it as 20H. Then here baud rate you have to calculate it. Baud rate how we are calculating? 28,800 divided by 2,400. The value is 12. The 256 minus 12, is 244. The 244 is converted into the hexadecimal by dividing 16, right, one value, then again 8, 84. So, remaining 84 5 times remaining 4, right. So, this is a F 15, the 15 is less than 16, you can stop it. So, F 4. So, the corresponding value was F 4 H. Okay. So, already we know how to calculate the baud rate 28,800, that is system clock divided by 12 again divided by 32. So, I used this. From that the given specified baud rate is divided, you will get it as 12, then it is subtracted from the 256 to convert into the number, because it is a 8-bit register, maximum value minus only we are giving. Then we have to initialize the SCON, which is a 8-bit content. So, you put both as 0 0. If it is 1 means it represents a 9-bit, then both the interrupt should be 0, then receiver enabled with the mode 1. So, 0 1 I will give it. So, finally, you read it, the value hexa value is 50 H. Okay. Then after initializing these 3, now you can start the timer. Start the timer. After starting, what will happen? The data will be received and stored in the buffer. S buffer only it will be stored, then we have to use the instruction to move to the P2. So, once it is P2 means by physically you have to made a LED connections from all the ports in the P2. Okay. In the breadboard you can make the connections 8 pins with the 8 LEDs. After executing the program, automatically the received bits will be displayed on your LED. So, this is the program what we have calculated in the previous one, right. These 3 values will be initialized by the T mode, move T mode comma 20 H. So, this symbol represents the hash symbol for its immediate data. So, the data 20 H is loaded in the T mode means in the corresponding format that value will be loaded. Then in the TH1 the F4, this is a baud rate I initialized. Okay. Then SCON is initialized with the specified mode with the enabled. Okay. So, after initializing these 3 I have to start the timer, I start the timer. Now, what it will do? After that, whatever you are pressing the switch, that will be read and stored in the SBUF. It automatically stored. Whatever the switches are pressed, based on that it will be stored. So, you have to press 8 times, then 8 values will be loaded here. Okay. 8 switches are pressed, or whatever you are transmitting the character. Suppose if you are transmitting the character one alphabet, suppose B means, along with that B its corresponding ASCII value with one start and stop bit, right, start bit and stop bit. So, first it will read the start bit, it will be discarded, then the 8-bit equivalent of stop B, character B will be loaded on the SBUF, right. After loading the D0 to D7, it will read the stop bit. Already the register also filled, then now it read the stop bit. During the stop bit, after reading that, now it will activate the RI. When the RI is activate means whenever the buffer is full, whenever the serial buffer is full, it will activate the receiver interrupt. So, what it indicates, now I received the data, it requests the controller to read the data, right. So, based on this condition, I will exit from the loop. Okay. I initialize the loop also based on the receiver interrupt. So, once it exit means the 8 bits are loaded in the SBUF. Now, the SBUF data is moved to the accumulator. We cannot directly move the serial buff to any one of the ports or any one of the register. Okay. So, it via the accumulator only you can process it. So, the SBUF is moved to accumulator. From the accumulator to now it moved to the port. Port 2 means here all the LEDs will be glow based on the ones and zeros value in the accumulator. So, after this process, now I will clear the RI, which is receiver interrupt, which represents to ready to receive the next byte. Okay. Suppose if you have a like the previous example we have explained with the good, right. So, first the G will be received, then it jump, then it will receive the O, right. If we are jumping, then we will receive the next character. So, this way we can also receive it, otherwise if it is only one means you can exit from here. Now, we will discuss one problem. Find the TH value to set the baud rate 9600 and 2400 if S mod is 1. Assume its frequency is 11.0592. Okay. So, based on this, what we came to know, the frequency value 11.0592, this is a system frequency, right. It should be divided by 12, what you get 921.6 kilohertz, this is also frequency. Okay. This will be divided by 32. This 32, either this will be with the 2 power S mod. S mod is 0, what we are doing, 2 power S mod divided by 32 we are giving, right. If it is S mod value is 0 means what will happen, 2 power 0 by 32, or if it is 1 means 2 power 1 by 32. So, here 2 power 32 which will give 1 by 32, here it become 1 by 16. That is why we are divided by 16 or performing with a divided by 32. So, here based on this concept, okay, S mod is 1. So, I will take it the value was divided by 16. The frequency which we assumed as 11.0592 divided by 12, right. Because of mode 1 we are divided by 16, we get the value was 57,600. Okay. So, this you have to calculate it based on this. After that, what is your required one? 9600 baud rate. In case of 9600 baud rate means 57,600 divided by 9600. So, this what it gives the value was 6. So, 6 means 256 minus 6, what you get? 250. The 250 value is a decimal value, we have to convert into the hexadecimal value. 250 divided by 16. 16 means what you get, one time, right, remaining is 4 plus 5 9, 90, 5 times, then 10 you have. So, you will write its corresponding hexa equivalent which is FA. So, FA you have to find, that is to be loaded in TH1. Okay. This is for 9600. Now, we have to find the hexa equivalent for 2400. So, for that already we have calculated 57,600 divided by your required value 2400. Okay. So, after dividing that you get the value as 24. So, 256 minus 24 you have to do it. So, you get it the value as 232. So, 232 is a decimal value, you have to convert into the hexadecimal by dividing 16. So, 16 means you will get the value as 1, then remaining is 72. 72 means 4 times it will comes, then you get the remainder as 8. So, this value is E and 8. So, you have to load it as E8H is a hexa value to be loaded in TH1. In today's session, we have discussed the two programs, how to write program to receive the data or how to transmit the data, like a particular word, or you can if you need you can transmit as a sentence also. So, that way you can do it for any kind of serial communications. First you have to activate the T mode for initializing the baud rate, then calculate the baud rate with respect to S mode is 1 or 0. Okay. Then after calculating the baud rate, its corresponding hexa equivalent to be loaded in the time TH1 register. Then based on the given specification you have to calculate the SCON. So, these three initialize, then you start the timer. After starting the timer, then you can repeat the process till the interrupt flag is set. During the transmission we are expecting the TI to set, during the receiving RI. So, based on that the transmission is over. In case of receiving, the data is available in the SPUF, right, then we have to move to accumulator, then wherever you want you can store it. So, with this I will wind the session. Thank you.